We're taking a look at the web view, Ajax, and cross-platform development under Android. Remember that everything that we can accomplish through HTML5 will run anywhere. So when we think about building a mobile phone application that's basically cross-platform, it's important to keep in mind that one of the paths to arrive at this cross-platform or vendor-neutral solution is HTML5 for the user interface. And when we look at the output of Java code running Android markup language compared to JavaScript running HTML, side by side we can't really see any difference, notice any difference as a user. So one way to save time and money is to build out an app first in HTML5 and use the native environment for the shell around that. So what we're going to do is to take a look at HTML5, JavaScript, and Ajax to build applications that we can see through a web view. And side by side we're going to see content that's coming from both the Android markup language combined with HTML side by side, and we'll notice that the user cannot see the difference between content that we render via HTML compared to content that we render via the Android markup language. It all looks the same. Now we're looking at two emulators. One emulator is the emulator on port 5554, that's here. Another emulator is on port 5556, and that's up here. So notice that when we run this application, that the message at the top, the 3 asterisks, hello world app dev. Basically what we're seeing here is that the application displays this message, and the content here is going to be updated via Ajax. So the first line of code is coming from rendering out of the Android markup language, and the second line that we see here is output rendered from HTML5, and we really can't see any difference other than the font. It's the same white background, but the fonts could be set to be identical. The point being is that whether we output render via HTML5 or if we output render via the Android markup language, the user is not going to know the difference at the time that the application is complete. So let's test this. We're running the emulator here, level 12 Google Honeycomb. We're going to load a file from Ajax. And in this example, the file is coming from the local file system under a folder in our project called Assets. And we access this programmatically through a different folder name once it's in the memory of the phone called Android Asset. Now also, we're going to take a look at how we can use Ajax and JavaScript to modify the DOM, the HTML here. So HTML5, JavaScript, Ajax, and we can see the content change. So the point is that whether we author the user interface rendering via HTML5 or Android markup language, there is, at the end of the day, there's no difference. The user is going to see the same thing. But one advantage to HTML5 is that HTML5 is going to run everywhere. It's going to run on BlackBerry, iPhone, Windows Phone, Android, everywhere. So let's pause and take a look at the code behind these examples and figure out how this works. We have button number 1, button number 2. We have this area right here which kind of looks like it's a text view, but it's actually an HTML web view. And then we have a text view here at the top. So let's take a look at the code. So in our project here, we have all the files that are open for this project. We could look at the Project Explorer to get a bird's eye view of all things. Remember that under the SRC folder, the source folder, we have our Java code. We can open that up. There's an onClick and an onCreate function. So the way that we're using onCreate is to initialize all things, and we're using the onClick button event handler for both of the buttons. And one of the tricks that we're going to take a look at is when the onClick event gets called, how do we sort out which button got clicked? And we know because the argument, the view argument, is a generic user control parameter, and by checking the ID of that user control, we can test which button got clicked. Also, notice that under the generated section, we see r.java. We see the IDs for button 1, button 2, and web view 1. So everywhere in the application that we see _XML, that means the object ID is only on the markup side, but we have a mirrored version of that also on the Java side. And when we see the _Java, that means that it's the mirror on the Java side. When we see the _XML, that's the version here that bridges the gap between Java and the markup language. So under Google APIs, we could see the reference to the Android open source and the maps from the Google licensing. Also, under this folder called Assets, we're looking at a globe icon because this is an HTML document that could be on the web or it could be on the local file system. In this example, we're putting it on the local file system, appdev android ajax file.html. So a big question is, how do we display content in the web view that lives in the local memory of the phone? So if we look at the resources folder and we look under layout, there's this file here. It's called main.xml. So under main.xml, we have the user interface. This is the entire user interface. We have a linear layout for the root. We have a title at the top as a text view. We have a web view that displays HTML5, button number 1 and button number 2. So keeping in mind that everywhere we see the reference to _XML on each of the buttons and also on the web view, that's the markup language version of that object. It's a pointer. But if we also go over into the raw Java, we could see references to that same object, but we're putting _Java at the end of it because it's a pointer from the compiled Java side, not from the markup side. But basically it's pointing to the same thing. Now, one thing that we learned in this example is that in order to execute JavaScript within the context of a web view, we actually have to set this property called set JavaScript enabled, and basically it's very similar to the permissions that we also set when we're looking at the manifest. So for example, use this permission Android name, android.permission.internet. That's something that is required in order to access a website like google.com that's not on the phone, it's out across the internet. But once we get to a local website or a public website on the internet, the second question is whether or not the web view turns off the JavaScript interpreter. And the way that we make sure that that's turned on is by setting this property here to true. So let's back up. The onClick event is something that gets called in reaction to clicking on one of the two buttons. But before that, we have the reference to the onCreate. So onCreate is the entry point to the application code. And what happens here is that the button B1 Java and the button called B2 Java are bound to the event listener, set onClick listener. They're bound to call this onClick because the class definition here has been modified to implement the onClick listener interface. So the onClick listener interface is part of view.view.android, and basically what it says is that the class that it's attached to, which is this class, it must implement one function called onClick. It has one parameter called view. Remember, a view is a user control, and a button falls under that category. In fact, to make that very clear, if we look for button, button.widget.android is implementing a view. So button is basically extending the base class of a view. So when the button click happens, either on the first button or the second button, we have a switch statement that sorts this out. Looking at the ID of a button, and we know the ID by looking at r.java. So r.java auto-generates integers for all the markup language objects. So if we see something that says ID, just like in HTML we would have an ID that's a text value. Well, here we have both the text value and also the integer number behind that, and that integer number is the only thing that the Java code wants to see. So when we go back over to the Java and we look at this code, this switch statement is going to trigger off of an integer. So whether it's button number 1 or button number 2 will perform a different task. Button number 1 will load content from Android_asset folder, and that folder correlates to what we call assets plural here under Eclipse, but it compiles down into this folder when it's in the APK file. Next, we check for button number 2, and if button number 2 gets clicked, we're going to load a different URL, and actually the URL is not a different web page. It's actually going to pivot down into the file that's already loaded, and it's going to call a JavaScript function here, appdev android JavaScript function, that has the job of updating the content of the HTML using Ajax style JavaScript and dynamic HTML. So let's find that file. It's right here, but before we open it, let's find it on the tree first. So we're talking about this file here. And basically it's a standard HTML document that contains JavaScript and HTML body. So the span tag here is something that we're going to update via its ID, appdev android HTML5 span. So we'll grab a handle to that by using this document.getElementById, And this references a text value here, and get element by ID is basically going to bring that back into here as something like an integer, just like under the Android environment. There's a difference between the text ID that we see in HTML versus the pointer in Java or JavaScript. So this is a pointer to a span. We could probably even put underscore int because it's probably an integer value, a hexadecimal value when it comes back. But we don't know that. We don't have to assume that. We can basically just think of that as a pointer to something. And we can reference it by this dot inner HTML and then passing in a new value to replace the content that's already there, which is this world by default. So when the app starts, we see hello world, but when we click on the button, we'll see hello Minnesota.